In machine learning, we're going to work a lot with tensors. And the idea is that data can have higher dimensions than just 2. So a tensor generalizes a matrix to higher dimensions. And to get a first feel of what that means, let's look at a simple example. So let's say that the data sets that you're used to are of the format. So let's just generate some random data here. So we're going to have 10 observations, and this is going to be one column, the column on inflation. And let's say that the average is 10 and the standard deviation is 2. And then we're going to have unemployment. It's going to generate in a similar way. So random dot normal. It's also going to have 10 observations, and this is going to be one column, the column on unemployment. And let's say that that's going to have an average of 0.1 and then some standard deviation of 0.02, and we're going to have GDP, which is going to be equal to TF random dot normal. Again, the same shape, 10 observations. This is going to be one column. Let's say it's going to be 100. Standard deviation 10. So then our data set would sort of look like TF. So we're going to concatenate the columns that we have. So that's GDP, inflation, and unemployment. And we're going to concatenate that along the columns. So putting one column next to the other one. And if we now look at the shape of this data, we basically have data in the format 10 rows and 3 columns. So that's basically a matrix. A matrix with 10 rows and 3 columns, and each column corresponds to one of these variables: inflation, unemployment, or GDP. Now to see the difference with what we're going to be dealing with in machine learning, we're going to import a very famous data set in machine learning, which is a data set of written numbers, along with the label for each number. Test labels. Data sets. So this is called the MNIST data set. Load data. And then if I look at the images that we're loading and we look at the shape of this thing, we're going to get the following. So it takes a bit of time to, it's already done so, it has loaded the data. So here what we have is 60,000 observations, so we have 60,000 rows. But an observation is not just a one-dimensional object here, an observation is a two-dimensional object. So our data set has 3 dimensions instead of the 2 dimensions that we had before. And to show you why that happens, let's simply look at one of these observations. So we're going to look at these train images. So let's look at the 5th observation. So that's index level 4, because we start counting at 0. So don't worry about this code. Binary, and then DLT show. Whoops. So an observation in our data set that we're going to be using later on for machine learning is actually a 2-dimensional object. So it's a handwritten number. So in this case it's the number 9. And the goal of the neural network that we're going to be specifying later on is to actually recognize these numbers, to recognize this picture as being the number 9. But the observation here is that the 5th element of this data set is a 2-dimensional object. Yeah, so if you again compare this to our own data that we had before, we could look at the 5th observation from that data and consider its shape. And the shape of that thing is just 3, because it has 3 numbers, a number for inflation, GDP, and a number for unemployment. Yeah, so this is basically a row vector with 3 columns. So it only has 1 dimension, so to speak. While the observation that we're going to be working with later on is something that has 2 dimensions. And if you think of doing something with video, that actually has 3 dimensions, because it has a 2-dimensional image, like the 9 here, but then that can vary over time. So there's going to be a dimension added to it. So one observation is going to be 3-dimensional. For each time period, I'm going to have 2 dimensions to have a picture of that video in that second, so to speak. And then as time moves forward, we're going to have different pictures. So we have different, in this case 28 by 28 pixels that change over time. So that's the reason why we're going to need tensors, because we have to generalize matrices in terms of the data that we're going to be using with. And that's exactly what tensor does. A tensor can have arbitrary number of dimensions, so it's not fixed to being 2-dimensional like a matrix. It can have 10, 20, 100 dimensions in principle. And that's what we're going to be working with here, to see how you can use tensors and how you can apply functions to tensors.